We made it to the final part of this week's notes, which is absolute value inequalities. So we're going to go ahead and combine our understanding of absolute value equations and combine them with inequalities. So how does that work? Well, absolute value inequalities are basically inequalities less than, greater than, throw in some equal to's in there, and absolute value bars. They're very similar to solving absolute value equations where you're breaking them up into those two equations, but the way we split them up depends on the inequality symbol. So if it's greater than, you're going to have one method on solving it. If it's less than, you're going to have a different method for solving. So let's start with greater than. If you have a greater than symbol in here, you're going to go ahead and split it into an or inequality. So similar to how we did absolute value equations, we'll take what's inside, which is x, and we'll set it equal to greater than positive 5. So notice all we did was keep it, right? But now we need to write or because it's an or inequality, compound inequality. And then to create the other one, we're going to do x. Now remember, we usually negate or make the outside number negative. But as soon as we negate it, we need to take that inequality and flip it. It's kind of like that rule we talked about when we divide or multiply by a negative, we need to flip the sign. Same thing here. So we're going to have two inequalities, one where it's greater than that value, and then the other one where x is going to be less than the negative value. So we're just flipping it. So this is only true for a greater than symbol. What happens when we have a less than symbol? What we're going to do is we're going to take what's inside and turn it into an and inequality. So an and inequality looks like this, where we have it between two numbers. The positive number should go to the right, and the negative number, which is the smaller number, should go to the left. So you now have an and inequality. And this only occurs when you have a less than symbol. So let's do some more examples. So a little reminder here, when you have a greater than symbol, like we do here, in an absolute value inequality, we're going to have to split it up into that or statement. So right off the bat, I go greater than symbol, absolute value. I need to split it into an or statement. Boom, split. So I take what's inside 4x minus 12, write it twice because I need to write two different inequalities. One is just going to be greater than 4. We keep it as is. The other one we have to negate, turn it into a negative, but then as soon as we negate it, we need to flip the sign. So one is greater than 4 and the other one is less than negative 4. And then that's the hardest part. The rest is just solving, which I know you guys can do. You got this. So add 12 to each side. 4x is greater than 16. Divide both sides by 4. X is greater than 4 is one possibility. Or another possibility. Let's go ahead and solve this one. So we're adding 12. Dividing by 4. So x is less than 2, or x is greater than 4. So we can always draw that graph just to make sure. So here's 0. You can see it's either greater than 4 or it's going to be less than 2. So those are going to be opposite directions. And you could plug any of these numbers into the inequality to make sure that they work. So 0 should be a solution, right? Because it's in that shaded area. So we could plug 0 in here. 4 times 0 is 0, minus 12 is negative 12. Take the absolute value of negative 12. It turns into a positive 12. Is positive 12 greater than 4? You betcha. So we're good, right? It's fitting into that case. Now that was greater than. Let's look at an example where we're using less than. That's what we're starting off with. Here we're starting off with a less than symbol. So I know I will have to break it into an and. But before I can, feel like that was really loud, but I probably scared the crap out of you. I'm sorry. But before we can do that, we need to make sure our absolute values are by themselves on the left-hand side. We have this -9 that's kind of in our way. Just move him to the other side. He doesn't belong there. He went over the inequality. It's not cool, dude. Go back to where you belong. That sounds like a bad joke. It's not meant to be that way. Sorry. Okay. He doesn't belong on the left of the inequality. He belongs on the right with the other constant. So add those together. So 36. Now that we have the absolute value by itself on the left-hand side, we can then split it. Since it's a less than or equal to, that means we take what's inside, put it in the middle. Boom. Draw our little less than symbols on both sides. We don't have to flip a sign or anything, just less than on both sides. And then we drop the positive 36 on the right and the negative 36 on the left. And then we're going to go ahead and solve it just using our handy dandy solving techniques. What you do to one side in compound inequalities, you have to do to all three. So 2y is less than 30. Go ahead, -6 is -42. Divide both sides by 2, run out of space. So this is y is between, the upper limit is 15, the lower limit is -21. So y is some value between -21 and 15. And you could draw that on the number line if you really wanted to. -21, +15, shade, shade, and then in between. So any number in between those two values will work for this. So 0 should work. 2 times 0 is 0, plus 6, 6, absolute value of 6 is 6, -9 is going to be -3. Yep, that's less than or equal to +27. So you can check a couple different values, right? Just plug them in and work through it. The key thing to remember here is your starting inequality will determine what method you use. So greater than, you're going to split it into an or. Less than, you're going to go ahead and break it into an and statement. Okay? And be careful about where the positive and negative values go. So hopefully that helped. Work on that one because this can be the trickiest method. So really work on it some more and feel free to reach out to me if you have any questions at all.